Oh, okay, yeah, we're back. This is, I guess, video 5. I really wish I could have just live streamed all of this, to be honest. We're going to start putting together our tap tower here. And you can see, we've got drain, we've got backsplash, boxes springing back. But first, before we really do much of that, I'm going to set this back aside. We're going to open and put together some of the stuff over here. So we got our shanks, and we got our faucets. So the first thing you do, we're going to pull apart everything. And I'm going to go through and explain why I do it the way I do. These always have just a massive amount of packaging. Like the series is me bitching about packaging. Alright, so cut apart, pull your shank nut off the back, your shank, and then your little plastic flange for the front. I don't know if you guys can see real well. Let's see if I can move you a little bit closer. There went my phone. I was sitting next to it. Alright. Again, I'm sorry about this. My main camera's having issues. So you got your shank, you got your flange, which goes on to the shank, just like that. And you've got your shank nut. In a previous video, I told you that I got these star washers to go on there as well. As you can see, it's got little teeth on the back, and that just goes right over there. And your nut goes on. Now, I like to kind of just install the faucets on there. One, it makes you handle every piece, so you look at it and make sure that everything's in good condition. It's brand new, doesn't mean it works right. So first thing you do is you check the back to make sure that that seal's in there. Make sure everything's tight, everything moves, and you put it on. So, see if you can see this. The shank has these little lines on there, and inside the faucet it's got corresponding little lines, so when it fits in, it fits onto those little lines and kind of locks it in place. Then the retainer nut goes on and screws into place and holds it in place. So when you tighten this onto your draft tower or box or whatever it's going into, hopefully you get this tight where this whole thing stays in place and you don't get any lateral movement, because that's bad. Well, it's mostly annoying. So hence why I got this little washer, which is a separate piece that'll help bite into the back of the stainless and hold it in place. Okay? If you have any questions, please ask. So, we're just going to go through and kind of put all of these together so that we've got everything in one place before we put them onto the draft tower. So while I'm doing this, God, wish I had more space. Because again, all the packaging garbage. So while I do this, let's talk about like how often you need to clean this stuff. So, I tell people constantly, you need to clean your lines every 2 weeks to cut down on bacterial growth and, you know, keep it in good shape. Now, a lot of distributors will come out and clean your lines, and basically what they do is they hook up a cleaning kettle to it, and it's just a fancy keg that you can fill with chemical and just run it straight through the lines. But most of them, at least in my experience, most of them, I'm not going to say all, don't yell at me, don't sue me, a lot of them, or at least the ones that, again, in my experience, they don't always take the faucets off and clean them. So your faucets have to be cleaned every 2 weeks, just like the rest of your system, like the lines do. And cleaning them, you gotta take it, your faucet, and you pull off that section, comes out. This section, which is the plunger, comes out, and this section comes off. They need to go in, soak in chemical, get cleaned out with a brush, inspected, make sure everything's in good condition. There's a little weep hole right here, which is kind of hard to see on the camera. You need to make sure that's clean because that helps depressurize the system. Make sure everything's in good shape and then put it back together. But I'll go into more of that in another episode. Hell, I've already done one video on cleaning faucets. They're never cleaned enough. And you guys are welcome to fast forward to sections of these videos that you want. I'm sure you don't want to stand here and listen to me ramble as I just put this stuff together. These are the videos that I really wanted to do. These are the videos. This is the reason that I started this YouTube channel, is so that I can get more information out about this stuff. People tend to be really tight-lipped about it for some reason. Draft systems are not complicated. They're really, you know, it's a delicate balance, sure. There's lots of little bits and parts, which can be intimidating, especially if you don't have a lot of experience, you know, building stuff, putting stuff together. So the basics of it are: beer wants to be under constant pressure, and that pressure so that the CO2 doesn't come out. So the sweet spot in temperature-wise on beer is 38 degrees. 38 degrees with 12 pounds of CO2 pressure will maintain the carbonation in the beer at 2.5 volumes of CO2, which a lot of beers are not 2.5, but 2.5 tends to be kind of the standard. I mean, it's what a lot of the big macros are. And because of that, all of these systems tend to be designed to run 12 pounds of CO2. Now, beer doesn't like to change. It doesn't want to move. It wants to stay exactly where it's at. So to make it do that, your system is 38 degrees. So that keeps that level happy. And then you have to keep 12 pounds of CO2 on there to keep carbonation in. So to get it from point A to point B, you have to build in 12 pounds of restriction from keg to faucet so that it maintains the same pressure throughout the entire system. A little complicated, isn't it? It's not as bad as it sounds. It really isn't. So, we use couplers from the keg to get the beer out of the keg and to get the CO2 into the keg. And it goes into what's called a jumper line. And the jumper line goes from your coupler to your wall mount, which I showed in an earlier video and I'll show again. And usually there is a certain amount of restriction built into that. So you know that all of your hardware is going to give you about a pound of restriction. So your coupler, your faucet, your shank is going to give you about a pound. Your jumper line is 3/8 vinyl generally, and that's going to give X amount of resistance. I don't remember off the top of my head, but that's pretty easily found. So from your jumper to your shank is where you need to get basically the rest of the resistance. So you do gain gain partial resistance from elevation. So if your beer, like your keg's on the floor, your line, you go up like, we'll say 3 feet, that gives you 1.5 pounds of resistance, because it's about 0.5 pound a foot up. And you can build that into the system. Now, the reverse is true as well. So if you go up 5 feet, come over and go down 2 feet, that's a gain of 1.5 pounds resistance because you lose a pound from the drop. So the rest of it has to come in the diameter of the line that's run. So at the end of the runs, you always want to go from bigger to smaller too. So like I said, your jumper line is usually 3/8. It could be 1/2 inch depending on how you're building the system. So you go from the 3/8 up, then you can go down to a smaller size or stay the same size. You either want to stay the same size or you want to drop down. So at the end of all these lines, we have what's called a choker line. And that's made out of 3/16 vinyl, generally. And that stuff has high resistance. So, 5.5, 6 feet of that stuff is 12 pounds of resistance. That's why most of your kegerators have, one little line, and it's usually about 6 feet long, and that's all the resistance you need. But in these big systems, this one, by the way, is for a short draw system. So it's inside a cooler and going just directly outside of the cooler. So pretty easy. Unfortunately, I don't have the full measurements of everything yet, so I can't pre-cut lines and get everything ready for that, because I don't know how big my choker lines will need to be. But it's not going far, so my guess is it will be, my chokers are going to be pretty long. I'm guessing about 3 feet of choker. So I'm going from the 3/8 up, the 3/8 jumper line up, and then I'll probably take 5/16 over and as far as I can, and then have my choker line, which will probably be about 3 feet of choker line per line. That's my guess. I have to sit down and do the calculations when I get there. By the way, all of this stuff, if you guys don't have this, get it. This is the shit. Has everything that you need to know inside here. Get it, study it, read it, live it. I've read that multiple times. As you can see, I keep them around. I actually have like 3 or 4 copies of it. I've also been to the Micromatic class, the Micromatic draft system course, and I highly recommend it. I've been doing draft system stuff for years at that point, but I was a little skeptical. I went to it, kept an open mind, and actually learned quite a few things. It really just kind of put all the puzzle pieces together. So in the puzzle, I was missing this piece and this piece and this piece, and like it really helped. I got a lot from it. Plus, you do get to use some other equipment that you may not have ever had any experience with. Like I got to use the pump system for cleaning draft systems. I'd never used one before. That was part of the training. And I just ordered one, so I did the class a couple years back before COVID, but I just ordered a pump system for a different system, which is cool. I'm looking forward to getting in. I haven't used one since that class, so I'm gonna have to relearn how to use it. Don't worry, there'll be videos on it. Yeah, just putting stuff together. The massive pile of garbage over here is getting huge. As you can see, it's already on video. Should I have turned on the pretty lights and made myself look better? The downside to the pump system is there's a lot of bits and pieces that you have to get for it. I mean, you look at it and it's like, oh, the pump's like the big fancy high pressure pump with all the bells and whistles, like $850, which, I mean, in my world isn't that bad, but it's kind of expensive. But then you have to order, you know, all the little jumpers that go from faucet to faucet, and all the couplers that attach the 2 couplers together to create the loop for it to go around, and all the other bits and bobs to go with it. So I don't know. To get a really nice pump system, you're probably looking in the range of like $1,500-1,800. Honestly, I'm not sure how much I spent. We'll see. Hopefully I don't get yelled at too much. I didn't get that from my company. I got it for my main job, my main company. Again, massive amount of garbage. It's the downside to this kind of thing. Especially when you're trying to be like more responsible for the environment. This one was a little crunchy going on, but went okay. Hey, not too many more. After this, I'll go ahead and turn this off, upload this video, and start another video where we're going to start installing these on the draft tower. After I do a little bit of cleanup. Again, if you guys have any questions on any of this stuff, feel free to put a question in the comment section. I'll do my best to answer pretty much anything, or maybe I'll do another video on answering your question. It'd also help if this bench were about this tall. All this bending down isn't helping. Of course, you know, it's not really a bench, it's just a couple sawhorses with my welding plate on it. Oh, that's something we can actually talk about while I'm doing this, or at least start the conversation. I keep saying, don't use brass. Don't use brass. Always get stainless. Always get stainless. Especially anything that's like nickel-plated brass. Stay away from that. Because that nickel plating actually comes off. And then you see the brass, and where does that nickel plating go? Into the beer. Ugh. I mean, who wants to drink little bits of metal? I guess if you want to drink Goldschlager, that's you want to drink little bits of gold, but it's not nickel. Also, as it comes off, the brass, which does have natural antibacterial properties to it, I will fully admit, from the copper that's in it. But it'll color the flavor of the beer, so you can get a metallic taste from it. Also, it does have some natural properties, but the beer is acidic. It's naturally acidic, so it's going to eat it. So those parts aren't going to last nearly as long as stainless parts. All of these parts that I'm putting in here, I expect this system to have little issue for 10 years. Now, that's with doing the proper maintenance, tearing them apart, cleaning it, doing all of that, replacing the jumper lines yearly, which you need to replace the jumper lines yearly. You know, that shit. But all of these bits, I expect this to last 10 years without any issue. Brass bits. Brass almost immediately starts to get eaten away by the acidity of the beer itself. So it can flavor the beer, so you get brass flavor. The nickel plating comes off and goes into the beer. You don't want that. As the brass is being eaten away, where does it go? It goes into the beer. Again, you don't want that. Also, it pits and can harbor infections, which is really hard to clean with your general, like, 2 or 3% caustic run through it. So again, nothing is good about brass. Stay away from brass, get all stainless components. And that is that. All 12 are put together, and I've got a massive pile of garbage over here, so I'm going to go ahead and finish this, upload it, get to cleaning up, and go back, start a new video putting this into the draft tower. So, cheers, see you in a bit.